Okay, in example 516, we're asked to find the integral from -5 to 5 of x cubed dx, and this is a typo, that should say the definite integral from -5 to 5 because we're given the bounds. So I'll change that in your notes a little bit later. Let's see here. So the curve looks something like this. It starts off and it goes through 0, 0, and then it curves up and goes through the same point right there. And so the way I have this drawn, it should have the same area on this side as on that side, right? Because it's going to go through like a point down here. It's going to go through -5 comma -5 cubed, or -5 -125, and then up here it's going through the point 5 comma 125, or 5 cubed. And basically, because this is an odd function, the area on the left side is going to be equal to the area on the right hand side. And so let's see what that does for our integrals. So we have the integral from -5 to 5 x cubed dx, and now that's equal to x to the 4th over 4, and I need to plug in -5 and 5. So I write down my function twice, so it's something to the 4th over 4 minus something to the 4th over 4. The first time I plug in 5, and the second time I plug in the lower bound, which is -5. And so in that case I get 5 to the 4th, which is, I think, 625 over 4, and then minus -5 to the 4th, which is also 625 over 4. And so we got that the area between the curve and the x-axis from -5 to 5 is 0, and the reason for that is that this first half has area -625 over 4 because it's below the x-axis, and the second half has +625, and so they canceled out actually. Okay, and that's going to be true actually for any odd function. If you start with symmetric bounds like -5 and 5, symmetric about the origin, and you have an odd function that spends half of its time below the x-axis and half the time above over that region, then the area is going to be 0.